Hello guys, welcome to today's class. In today's class, we'll be discussing the differentiation of implicit function. Now, to help us understand how to differentiate implicit function, we need to know what an implicit function is, what an explicit function is, and how we differentiate them. Now, if you are given a function in the form y equal to f of x, for example, I have y equal to x squared plus 2x plus 1. This function is said to be an explicit function. Explicit function because it is expressed as y equal to a function of x directly. This is y equal to a function of x. This is x squared plus 2x plus 1. Y directly equal to a function of x. And this y is in its linear form. That means the highest power of y here is 1. So it is expressed explicitly. Now, but there are some functions we see given y squared plus x squared equal to 0, for example. This is not a direct function of x. This is y squared plus x squared equal to 0, not written as y equal to something for a function of x. Now, this function is said to be written as a function of x comma y equal to some constant. Now, this is what we call an implicit function. So when a function is not written directly as y equal to some function of x, instead it is written as a function of x and y, we still know that y is a function of x. Then we say that that function is in implicit form. Now, for example, I have something like x squared y plus 2xy plus sine x equal to 4. You see, this is not expressed directly as y equal to some function of x. Instead, we see a product of x and y in this function. So this function is said to be written implicitly. And this is an implicit function. So we want to learn how to differentiate implicit function as opposed to how we differentiate explicit function. Now, the rule of differentiating implicit function is the usual way we differentiate explicit function. But in this case, when you want to differentiate implicit function, whenever you differentiate y, you return dy dx. I will show some practical examples as regard to this. Okay, let's look at this practical example. Now, in this function, we can see that y is not written directly as y equal to some function of x. Instead, we see a product of x and y. And so we say the function is written implicitly. All right. So how do we differentiate implicit function? Let's look at this. We say solution. So let's rewrite the function x squared y plus sine x equal to 4. Now, to differentiate a function implicitly, we approach it the way we do our normal differentiation. But whenever we want to differentiate y, which is the dependent variable, we return dy dx. So what we do is this is a product rule. So because we have two functions multiplying here, and what does product rule say? You hold the first term, differentiate the second one, plus hold the last one, differentiate the first one, right? So we'll have x squared. We now differentiate y with respect to x. Now, normally if you differentiate y, you have 1. Just like when you differentiate, if you have x, differentiate x, you have 1. You want to differentiate x with respect to x, you have 1. So when you differentiate y, a single variable function, you have 1. But whenever you differentiate y, you return dy dx. That is the rule of implicit differentiation. Whenever you differentiate y, return dy dx. So we've taken hold the first one, differentiate the second one, because it is y, we return dy dx. Then plus, to complete our product rule, we hold y, then differentiate this. When you differentiate x squared, you have 2x. We are not returning the y dx because we are differentiating x. So whenever you are differentiating the independent variable, you don't return dy dx. You only return the y dx, or you only return the differential of the dependent variable with respect to the independent variable. All right. So this is this plus now sine x. This is just purely a function of x. So we don't return the y because there's no y here. So we differentiate sin x, we have cos x. And then equal to differentiate this side, we have 0. What's the next step? The next step is to simplify this and gradually group all the terms without the y dx to the right hand side. So we have this times this, we have x squared dy dx plus this is 2xy. Now, it doesn't matter whether I write 2yx or 2xy, but I prefer to write it x and y, more like in alphabetical order. So plus cos x equal to 0. Remember how we got the 0? Differential of a constant term is 0. That's how we got 0. So gradually we push every time. We collect like terms. We keep the y dx on the left hand side. So we have x squared dy dx equal to, we push all of this to the right hand side, minus 2xy minus cos x. So from here we'll have, okay, so we have x squared dy dx equal to this. The next step is just to make the y dx subject to the formula. So we have dy dx equal to, on the right hand side we have negative 2xy minus cos x. Then divide both sides by x squared. And this gives us our dy dx. That's just how to differentiate implicit function. We'll look at more examples to better understand how to differentiate implicit functions. Okay, let's look at this example too. To differentiate this function implicitly, why are we differentiating implicitly? Because we have a function of x and y combined together. It is not written explicitly like y equal to some function of x. But here you see function of x and y on the left hand side. So we need to use implicit differentiation. So to differentiate this, we tackle this as product rule. But remember, whenever you're differentiating y, you return dy dx. But when you're differentiating x, you don't return the x dx because the s dx is just 1. So whenever you're differentiating y, you return dy dx. So to differentiate this product rule, you hold the first term, you differentiate this. Whenever you differentiate y squared, it's more like when you're differentiating x squared. Differential of x squared is 2x. So you differentiate y squared, you have 2y. But because it is y you are differentiating, and y is a function of x, y is the dependent variable, you return dy dx. So we have dy dx. Now, this is hold the first term, differentiate the second one, plus then we hold the second one, which is y squared. We differentiate x. Whenever I differentiate x is 1. And so we've completed this product differentiation of these two functions. So we'll move to the next one. Now, this is the differential of, we want to differentiate cos squared y. And in previous videos, I've explained how to differentiate cosine functions, trigonometric functions. So now let's look at it again. How do we differentiate cos squared y? You remember, this is more like cos squared y is the same thing as cos y all squared. So we can use the idea of chain differentiation to differentiate this. So first, we differentiate the inner function. When you differentiate the inner function, you have minus sine y. When you differentiate cos y, you have minus sine y. And remember, you are differentiating y. You return dy dx. And then, differential of anything raised to power 2 is 2 cos y. So we'll write this out. This is negative sine y dy dx dot 2 cos y. All right. So that's the differential of this. You differentiate cos y, you have minus sine y. But because you're differentiating y, you return dy dx. Now, this is cos squared. So differential of cos squared is 2 cos y. So you have this. On the right hand side, differential of 3, you have 0. And so we continue with this simplification. This is 2xy dy dx plus multiply this, you have y squared. Then multiply this, you have a negative. I would prefer to bring this one first. I have 2, because this is multiplying this, commutative rule of multiplication. So I can bring this one first. I have 2 cos y sine y dy dx equal to 0. All right. Now, what's the next step in this process of implicit differentiation? We make sure all the dy dx be on one side, then every other term to the right hand side. So we have 2xy dy dx. Now minus, this is together, 2 cos y sine y. Please, this is not a fixed pattern. You can actually have 2 cos y, 2 sine y before the cos y, but it doesn't matter. So we have this is dy dx. Now this moves over, I have negative y squared. And then the next thing is to factor out dy dx and make it subject to the formula. If I factor out dy dx from this, if I factor out dy dx, I have 2xy. Factor out dy dx from this, I have 2 cos y sine y equal to minus y squared. Now the next step is just to make dy dx subject, which will be dy dx will be equal to this divided by this factored value. So this is negative y squared all over 2xy minus 2 cos y sine y. And this is my dy dx.